Yeah, hello student. This is the fourth part of functions. Functions topic is very important for calculus. First chapter for calculus. Okay, so today I am going to explain some more types of functions. Initially, I explained what is algebra function, polynomial function. Okay, like that. Some more types are there. So today I am going to explain those. Yeah, okay, students. Today's first type is constant function. F from R to R, f of x equal to k, where k is a real constant. What is the meaning of that? Actually, everyone knows the definition of a function. The relationship between independent variable and dependent variable. For example, x equal to x square plus 1, then I can say that y is a function with respect to x. Or in other words, I can write f of x equal to x square plus 1 only. If x is input, f of x is output or y is output. So input is varying, output also will vary here in this case, but in this example, your output is constant. Outputs won't vary such a way that a function is defined. Such function is called constant function. For example, f of x is given as 3. What is f of 1? 3 only. What is f of 2? 3 only. What is f of 4? 3 only. What is f of 0? 3 only. F of root 2? 3 only. What is the meaning of this? All x's are paired with 3 only. Such function is called constant function. If you want to draw Venn diagram for this, for example, observe students. Yeah, f is a function from a to a set to a to a set to a. Some elements are given here, something r to r you can write. In examination they gave r to r, no problem. All the elements 1, 2, 3, root 2, 4, all are paired with a constant k. For example, 4, all are paired with 4 only. All elements are paired with 4 only. Such function is called constant function. Some more elements are there here, but images is only one. What is the meaning of that? Range of constant function is singleton set. Only one element, range. All the elements of domain are paired with a single element. Such function is called constant function. Observe here, definition also. Observe here. F of x equal to k, for every x belongs to domain. They should write like that. I will write again. Okay, students listen. F map R to R, a function defined by f of x equal to k for every x belongs to domain of function, domain of f, for some constant k belongs to codomain. Okay, this is the definition of constant function. So I want to write in Venn diagram. Say all these elements are paired with only one element. All these are paired with only one element. That is range of constant function is a singleton set. So this is important. Range of a constant function is singleton set. So graphs of functions very important. That's why here I wrote a graph. This is x-axis. This is y equal to k. Okay, I think understood. Again I will explain you people. You write down this one. Okay, I think completed. Now graph is important. Graph of constant function. Okay, what I am saying, for example, I want to draw the graph of f of x equal to 3, constant function only, for every x belongs to R. So what is f of x? Y only, output, y equal to 3. Whatever makes your y equal to 3. That's why first of all draw y axis and x axis. Here 1, 2, 3, 4, like that. Here 1, 2, 3, 4. You know how to draw the graph of some simple function. If x is taken as 1, what is y? 3 only. 1 and 3 here dot, 2 and 3 here dot, 3 and 3 here dot, 4 and 3, 5 and 3, 6 and 3, 3.1 something 3, 4 point something 3, 4 point something 3, all. Means every x have y is 3 only. That's why you get all these dots, join all the dots, you get a straight line. This straight line is the graph of f of x equal to 3. F of x equal to 3. What is the meaning of this? The graph of constant function is straight line which is parallel to the x-axis. So according to the, my diagram here, y equal to k, y equal to k. What is this? Actual x equal to 3 line. No, this sorry, y equal to 3 line. Always y 3 only. No, x is varying. Y equal to 3. A line parallel to x-axis 3 units from x-axis. No, y equal to 3. That's in our definition. What I told here, f of x equal to k. No, that's why y equal to k is a line parallel to x-axis. So y equal to k line is the graph for this constant function. For this constant function, this. Okay. So k may be 3, k may be 2, k may be 0 also even. Okay. That's why I explained about constant function and constant function concept completed. So the range is singleton set. All the elements of domain are paired with only single element. Okay. So next, identity function, another important one, identity function. First of all, I will explain roughly. In previous type constant, all x's are paired with a constant. But in this function, all x's are paired with x only itself. Means what is f of 1 equal to 1, f of 2 equal to 2, f of 3 equal to 3, f of 0.5 equal to 0.5. Such function is called identity function. Every element is paired with itself. I want to write the definition here. Again, I want to write the definition. F maps R to R or A to A. I want to write A to A. So that f of x equal to x for every x belongs to DOM, or I can write A here. Then f is called identity function, and it is denoted by I instead of R, your R is a function from A to B, like that. You always will write I is a function from A to A. A to A, important, no? A domain and codomain should be same to define identity function. A to A. Don't think that A to B. If A to B means B should be equal to A, then only identity function will define. Simply will write IA means what the meaning of IA means? I is from A to A. IB means I is from B to B. Okay. So all the elements are paired with itself only. Such function is called identity function. Okay, now I want to draw the graph of this. Okay. So I already is there, but again I want to run f of x equal to x. F of x, y equal to x. What are the solutions? X is 1 means y is 1. X is 2 means y is 2. X is 2.2 means y also 2 point, like that. Okay. To draw the graph of this, you should draw y-axis and x-axis. Okay, students. Yeah, 1, 2, 3, minus 1, minus 2, 1, 2, minus 1. Okay. X is 0, y is 0, here only. X is 1, y is 1. X is 2, y is 2. X is 3, y is 3. X is minus 1, y is minus. All these dots, if you join, form a straight line. This straight line is the graph of identity function. I can say this y equal to x line. Y equal to x line passes through origin. Okay, and it is the bisector of first quadrant and third quadrants, because these two angles should be equal. You can learn that concept later. So what happened? Y equal to x is a f of x equal to x is a identity function. Okay, Ranan. Okay, constant function and identity function I explained. Next, modulus function. Here onwards I can say piecewise functions, important. So why I am saying piecewise? In previous all type of functions, rule is same. F of x equal to x for x belongs to R, or f of x equal to x square plus 1, or f of x equal to sin x, like that. Only one rule. But here piecewise rules, piecewise, not one rule. Say f of x equal to x plus 1 for some x, f of x equal to x minus 2 for some x, f of x equal to x plus 3 for some x. See, such functions are called piecewise functions. So first piecewise function is modulus function. So already you discussed this in previous chapter. Again I want to explain modulus function. So already you know how to define modulus of a real number. Again I want to write modulus of real number. Real number x denoted by this symbol and defined by important. Already in basic inequality we learned about modulus function. Modulus of x equal to x. Modulus of x equal to minus x. When modulus of x greater than or equal to 0. When modulus of x minus x x lesser than 0. Okay. So instead of writing two equalities, what will write? I will show you. You need to write a bracket and you write only mod x. This is called piecewise function. This is called modulus function. Okay. This is modulus function. Now I want to draw its graph and I want to explain what the domain and range. Okay students, observe Nana. Okay. F of x equal to mod x. This is modulus function. For x belongs to R, every real number, this should be defined. Here only you can say the domain is all real numbers. Okay. Or another words I can say the y equal to mod x. Or another words I can say that y equal to x for x greater than or equal to 0. Y equal to minus x for x less than 0. Now I want to draw the graph of this first of all. First y equal x graph, y equal x. Already you know y equal x is straight line passing through origin. So this is y equal to x. See should for this x is positive, corresponding y here. For this x corresponding here. For this x corresponding here. But what is the meaning of that? We can't take negative x's here, no? Your x should be greater than or equal to 0. Means what is the meaning of that? Your graph will be this one only. Means we can't take this portion. Okay. The graph of y equal, actual y equal x is total straight line only. But what input is restricted, no? Input is from 0 to infinity only. That's why 0 to infinity, your input 0 to infinity, your graph should be this one only. You won't get this portion. The graph in which first quadrant only the required graph. One thing. Next y equal to minus x graph I want. Y equal to minus x. X is 1, y is minus 1. X is 2, y is minus 2. Okay, x is 1, y is minus 1 here. X is 2, y is minus 2 here. Yeah, x is taken as minus 1, y is 1. X is taken as minus 2, y is 2. X is minus 1 here. So this is a straight line represented by y equal to minus x. But what you want, your inputs are lesser than zeros. These x values you can't take. These x values should take according to definition. If x values are taken as negative, automatically this is a graph. This portion won't exist. What is the meaning of combination of these two means for this graph and this graph. So V-shaped graph is the graph of y equal to mod x or f of x equal to mod x. Okay, student. Yeah, students, important modulus function. Yes, this is the graph V-shaped. So passing through 0, 0. For this x, corresponding y is here. For example, this is 1. What is output? 1 only. X is taken as minus 1, their output also 1 only. Okay, for x equal to minus 1, y equal to 1, your output is 1 only. Okay, so this is the graph of modulus function. Now I want to explain about the domain. Any x, y defining, you take any x. For this x, y is defining. For this x, y is defining. Any x, y is defining. What is the meaning of that? Domain is all real numbers. I will write dome of mod x is all real numbers. Range important. Range means outputs. F of x equal to mod x. Already the modulus of x is non-negative real number. Means your outputs are close to 0 to infinity only. We get negative numbers. Y equal to mod x. Whatever be x, your y is non-negative. 0 or greater than 0 only. Observe here. In this graph also, for this x, your y is here. For this x, your y is here. For what x, y is here? No, such x won't exist. No. So all your x, y value should be 0 to infinity only. 0 to infinity only. Understood? That's why what I can say, these are the x values, y values are closer to 0 to infinity. Now I can say the range is closer to 0 to infinity. I will write that. Range of mod x is closer to 0 to infinity. This is important. Okay, student, this is about modulus function, piecewise function. First piecewise function. Second piecewise function, signum function. Signum. You will write SGN x in examination. You will write SGN x means signum function. Signum of f of x. Signum function or signum of f of x also correct. That is not a big problem. Actually, signum x means signum function. I want to explain what the definition, draw everything. This is also a piecewise function. How the mathematics are defined? Listen. F of x equal to signum SG or SNG, whatever it may be. SGN is best. X means mod x by x for x not equal to 0. 0 if x equal to 0. This is the definition of signum function. Students, listen, Nana. Signum function definition is mod x by x when x is not equal to 0. 0 when x equal to 0. Somebody will ask what is the value of signum of 0, means you can say 0 only, because signum is 0 when x equal to 0. Somebody will ask signum of 2 is equal to what? Signum of 2 equal to what? Signum of 2 means 2 is not 0. This rule should use. This rule should use. This rule should use. What is signum of 2? Signum of x, instead of this x, here x you write x. No, instead of this x, what should write? No, 2. So mod 2 by 2. Mod 2 means 2 only. 2 by 2 what? 1. Signum of 2 is 1. Somebody will ask what is the signum of 3? Signum of 3 is mod 3 by 3. Mod 3 3 only, no? Mod 3 3 only, no? What is the value? 1 only. Somebody will ask what is signum of minus 4? Signum of mod of minus 4 by 4 minus 4. Mod of minus 4 by minus 4. Understood? Mod of minus 4 4 only. By minus 4. What is that? Minus 1. Signum of minus 4 is minus 1. So somebody will ask what is the signum of minus 7 by 3? According to the definition, what you can write now? Mod of 7 by 3 by minus 7 by 3. That is plus 7 by 3 by 7 by 3. That is equal to minus, this here minus 1. What happens? Sometimes you are getting 1, sometimes you are getting minus 1, sometimes you are getting 0. Only 0 and 1 and minus 1 only you are getting outputs. Observe here, no? Clearly. Taken 2 is taken 1, 3 is taken 1, minus 4 is taken minus 1, minus 7 by 3 taken 1, root 2 is taken 1, minus root 2 taken minus 1. Understood? So this is the definition of signum function, important function, difficult function. Okay, students. See here. See here, definition. Signum of f of x defined by mod x by x or x by mod x for x not equal to 0. Not printed correctly. Okay, students. So first rule is for x not equal to 0. This is for x not equal to 0. This is for x equal to 0. For what? 0 x equal to 0. Okay. Now you can rewrite it. Again you can rewrite it. What is given I will show you again. Yeah. F of x equal to SGN x. How they define? Mod x by x or x by mod, that is not big problem, 0. What values of x? X not equal to 0. What values of x equal to 0? Again you can divide in two pieces, no? X a number which is not greater than 0 means x is greater than 0 case, x is lesser than 0 case. X greater than 0 case, what is the mod x? Mod x equal x only, no? X greater than 0 case, mod x equal x only, no? What happened? Mod x makes x by x 1 only. So what happened? I can write 1. I will write here 1. For what values of x? X greater than 0. So if you take x values lesser than 0, so x lesser than 0, what is the modulus of x? Minus x only. So minus x by x minus 1, minus 1 for x less than 0, 0 for x equal to 0. So again now you can rewrite a signum function as, students listen, f of x equal to signum of x equal to 1, or you write first minus 1, 0, 1. For what values of x? Minus 1, x less than 0. What values of x? 0, x equal to 0. What values of 1? X greater than 1. So this is final signum function. So this definition should remember. Whatever we x greater than less than 0, your outputs are minus 1. If x equals 0, 0 only. Whatever x value is greater than 1, your outputs 1. Only outputs are minus 1, 0, 1 only. Range is only a set having 3 elements, that is minus 1, 0 and 1. But domain is all real numbers. Okay. So I want to draw a graph of this. Students, listen. Already given here graph. How to remember, that is important. This y-axis, the x-axis. Okay, students. Here 1, here minus 1. X is 0, y is 0. 0 comma 0. I can say 0 comma 0. Here only, no? 0 comma 0. 1 is taken. 1 comma 1. 1 comma 1 comma here only. 2 taken. 2 also 1 only, no? Just now explained. 2 also 1 only. 2.1 also 1 only. 2.2 also 1. 2.3 also 3 1 only. 5 1 only. All the values are greater than 0. Your outputs are 1s. You get a straight line. So important thing is here diagram is not clear, Nana. X is 0, y is 0. Here thick circle, here should be open circle. Because 0 plus means 1. 0 plus means what? 0.0001 is taken as x. Your output is 1. Understood? X is 0.0000 nearer to this means x equals 0.000001, also y equal 1 only. That's why here you need to write open circle. This is not the correct diagram. Here open circle should be. Okay. X is 0, 0. X is minus 1. X is minus 1. Y is minus 1. Correct or not? X is minus 2. Y is minus 2. Okay. That's why what happened for this x here, like that, you get another straight line. Here also open circle, because f of 0, 0 only. F of 0 minus 1. F of 0 for this x value, output is minus 1. So this is the final graph of signum function, students. Should don't confuse. You need to write here open circle, and here thick circle. This is exact diagram of signum function. Okay. After that, domain and range. Just now I explained. No, domain is all real numbers. Range is only set having 3 elements. Only 3 elements. minus 1, 0, 1. Okay. Oh no, this is very important. Greatest integer function. This type of functions already explained trigonometry, but again listen, Nana. Greatest integer function. Okay, students, listen. First of all, I want define oral definition for greatest integer function. Students, listen. Take a number line, Nana. Number line sense real number line. 0, 1, 2, 3, 4, sorry, minus 1, minus 2. Like this is the real number line. X is any real number line. Sorry, X is any real number. Its greatest integer is denoted by this symbol. What the definition I will tell. Take any real number on this, anywhere, your wish. So I want to take a real number here. What is that? 2 point something. Now identify the integers which are lesser than that real number. Integers I am saying. Integers. Lesser than the real number. Integers means 2, 1, 0, minus 1, minus 2, so on. Infinitely many. Among all those, which one is greatest? 2 only, no, obviously. That is called greatest integer of that real number. Or step symbol you can read as step of 2 point something 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 is equal to 2 according to the definition. Okay. Take one more real number. I will explain. For example, your real number is here. For example, here. For example, that is 1.7342. You want to find its step. Actually, we read as a step of 1.7432. Why the is read as step? I will explain later. Just step 1.732 you want. According to the definition, we want to identify all the integers lesser than that real number. 1, 0, minus 1. Among all, greatest one only. Greatest one. Don't think that minus 1 is greater than 1. That is wrong. No, 1 is greater than minus 1. among all the integers 1 is greatest, that's why this should be taken as 1. Okay. So for example, your x is taken as 3 alone, 3. If your x is taken as 3, what is step 3? This is interesting. Now here what happened? We want to identify the integers lesser than or equal to that real number. Actually, here also I want told like that, lesser than or equal to that real number. This number is taken. Identify the integers which are lesser than or equal to that real number. Integer, no, I am saying that this is not integer. That's why I use it 2, 1 and so on. If x is taken as 3 alone, now we want to identify the number of integers which are lesser than or equal to that number. 3, 2, 1, so on. Among the greatest one 3 only, no? That's why step 3 equal to 3 only. This is oral definition, an important definition. For example, your x is here, for 0.00007 is taken. You want to find what is the greatest integer. According to what is my definition? Identify all the integers lesser than or equal to that real number. This is not an integer, no? That's why 0, -1 are required integers. Among all, greatest one is 0 only, no? That's why step 0.00 something also 0 only. For this real number also 0 only. 0.0008 is 0 only. 0.002 0 only. 0.03 0 only. Okay. 0 is only taken as x. Step 0 only. Okay. Now, students, interesting. If x is this, your x is this. What is that, Nana? -1 point something. Should take care. Step of -1 point something equal to what? Don't confuse. Some members saying that here 2, no 2, here 1, 1. That is not correct. Actually, here -2 is the answer. Step of -1 point something is -2. Because this is your real number. -1 point something, -1 point something here only. Identify the integers which are lesser than or equal to that real number. So -2, minus among all. Greatest -2 only, no? That's why step of -1 point something equal to -2. Don't confuse. Step of -2 is taken. -2. This number is taken. That one only, no? That is step of -2. So step of -7.43. Don't confuse. Don't write -7. -8 is the answer. Sorry. -8 is the answer for this. -7 point something. For example, somewhere here -7, here -8. -7 point something here only, no? Here only, no? The integers lesser than that number is -8, -9, so on. Among all, greatest one is -8. That's why step of -7.43 equal to -8. So in this way, you can define the greatest integer of a real number x. Now I want to write actual definition. X is any real number. Listen all of you. X is any real number. I will write here. For any real x, there exists, the symbol in mathematics read as there exists an integer n such that n lesser than or equal to x less than n plus 1. Such n is called greatest integer of x. Greatest integer of x. And it denoted by step x equal to n. You can read as step. Why you want to read as step? I will explain later. Step x equal to n. So observe here. What is the meaning of this? So 2.1 is taken. What is the definition saying that there exists an integer? Surri 2.1 lies between 3 and 4 only, no? Left hand side integer is taken as a step of this according to the definition. See, r equal to here, r equal to here, r equal to. Okay, so what I can say 3 actually 2.1 lesser than 2.1 lies between 3 to 4 only, no? Okay, what the definition saying that step of 2.1 is nothing but 3. 4.3 is taken. 4.3 lies between what, Nana? 4 and 5 only. Step of 4.3 taken as 4. 7 is taken. Just 7 is taken. What is that? r equal to will get here, r equal to will get 8 only. 7 equal to 7, actually 7 equal to 7 less than 8. This 7 is taken a step of that. Oral definition I explained, no, by using oral definition only we got this definition. Important students, very important. Okay, this one is very important, definition important. Yeah, actually what you call indicate integral part of x, GIF, you can write GIF, you can remember as greatest integer function, GIF, you can remember as GIF, greatest integer function. Okay, now I want draw its graph and properties. First of all, graph. Okay students, yeah, listen, why now I can explain why they are called step function. Here 1, here 2, for example 3, here -1, here -2, here -3, here 1, here 2, here 3, here -1, 1. I think everyone knows how to draw the graph of functions, no? That is important, no? Without graphical knowledge you can't deal calculus, none. Very important, should learn how to draw the graph. Now my function is what the function? F of x equal step x, my function. What is the y equal to step x function? Now I want to prepare the ordered pairs to draw the graph. Now if x is 0, y also 0 only. X is taken as 0.1. What is y? 0 only. X is taken as 0.01. What is y? 0 only. Understood? X is taken as 0.9. What is y? 0 only. X is taken as 0.99999. 0 only. Y 0 only. X is taken as 1. Y also 1. X is 1.1. Y is 1. Okay. Such a way that I want to identify all these ordered pairs on the number graph paper, or I can say coordinate plane. 0 0 here only. 0.1 0 here only. 0.2 0 here only. Understood or not? 0.2 0 here only. Here only. Here only. Here only. Here only. 1 1 1 will jump. Graph will jump here. So what is the meaning of the if x is taken as 0.99999 and also 0 only. 1 is taken 1. That's why actually here you need to draw open circle. Here thick circle. So your graph will be like this. Thick circle and this side open. What I mean here 0 nana, here 1 actually. What is the meaning of this? X is 0, y is 0. X is 0 point something 0 only. 0 point something 0. 0 point something 0. 0 point 0.99999 also 0 only. But 1, the automatically is jump to the value of 1. See here 1. So 1.1 1 only here. X is here, y is here. 1.2 here only. 1.3 here. 1.3, 1.4, 1.5, 1.6, 1.7, 1.99999 and also 1 only. But x is taken as 2, y is 2 here. What of here will jump, graph will jump. So here thick circle and this side open circle. So here thick circle at 3 open circle. At here thick circle, this side open circle. Okay. -1 -1 only. Open circle. -2 -2 only. Open. So this is a graph of step function. This is a graph of greatest integer function. We are getting steps, no? Steps. See, the graph is in the shape of steps. That's why the function is called step function. That's why the graph is named by step function. Very important graph, Nana. What is open circle, what is thick circle is important. This value is included and this value is not included. That's the meaning. Open interval, closed intervals are there, no, with us. Closed 2 to 3 means what is the meaning? 2 is included, 3 is included. If this side open means 2 included, 3 is not included. Just like that. Okay, thick circle and open circle. So what is the meaning of this? For example, this piece is taken. This is the graph. For x values are taken from 1 to 2. This is the graph. 1 only. 1.99999 1 only. But 2 means jump. Will jump to 2. That's why this is the graph of step function. Okay, Nana. Now I want to write a domain and range, Nana. Important thing. Listen, students. Domain and range. Dome and range. domain, sorry what I wrote wrong, dom, D-O-M, R-O-M what, domain of step x equal to all real numbers. Any real number you can take, not the problem. For this real number also you can take, this real number you can take. Range is very important. Identify what the range. You are getting only integers, observe. Sometimes you are getting 1. You won't get, for example, step 2.3 means what, nana? 2 only, no? Won't get 2.3, won't get another. Always you get integers only. Sometimes 2, sometimes 3, sometimes 0, sometimes -1, sometimes -2. What is the meaning of that? Your outputs are only integers, only integers. That's why range of f of x is integer z. Z should take care. Z is the range of step function. Capital R is the domain of step function. Very important. How to remember means GIF, greatest integer function. Yeah, students, what I explained here, the graphs, how they given like this. Yeah, see here. I used an open circle. They used like a semi-open. So same meaning is same. Meaning is same. All give same meaning. This is included. This is not included. Same meaning. Okay. Yeah, this is the step function. Its domain and range I explained. Okay, students. This is a very important function, greatest integer function, because we have several properties. Yeah, here some properties are given. Yeah, one by one I want to explain, students. So this is easy only for us. If step x equal to -1, your x values are taken -1 to 0. Step x equal 0, your x values are taken 0 to 1 and included 0. Your x value is taken as 1 to 2, so your step is 1 like that, and so on. Okay, domain of step function is all real numbers. Range of step x is integer, just now explained. Yeah, this is very important. Actually all are important, and especially this is very important. Step of x plus k equal to step x plus k you can write only when k is an integer, then only you can write, otherwise you can't write. Step 2.7 plus 3 given ma. Actually what is that? That is 5.7 actually. What is step 5.7? 5 only. This can be written as, according to the rule, step 2.7 plus 3 separately you can write. Step 2.7 what? 2. 2 plus 3 what? 5. Same answer we are getting. Don't think that step x plus y can be written as step x plus step y. Wrong. I will show you. Step 2.9 plus 1.9 given. If you write this as, like this, what happened I will show you. 2.9 plus step 1.9. Step 2.9 means what? 2 only. 1.9 means 1 only. Total answer 3. What if this is true, so what saying that this value is 3 only, but actual value what, nana? 2.9 plus 1.9, 2.9 plus 1.9, 18, 2, 3, 4.8, that is actually 4.8. Step 4.8 what? 4, but what got here? 3. That's why step of x plus y not equal to step x plus step y. If this is integer, you can write. Friends, again I want to say, na, step of x plus y equal to step x plus step y if y is integer. X and y are integer, no problem. Especially I am saying about with respect to y. Y is integer, directly you can write y integer, step of y only, no? That's why what is given here important. K is an integer, negative or positive, no problem. K is an integer and x is any real number. Then step of x plus k equal to step x plus k. Very important property of GIF. Okay. Next, nana, interesting. This is also another interesting. Step of minus 2.3, what? Actual value minus 3 only. Step of minus 3.4, what? Minus 4 only. No? Okay. What the definition is saying that if x is a step of minus 7, what? Directly minus 7. Means step of minus x equal to minus x when x is integer. X is integer. For x belongs to z happens. But here I can't say that step of minus 2.3 equal to minus 2.3. No. Okay, if x is not integer, what happened here? Clearly given. Step of minus x equal to minus x. So if x is integer, x is actually should write integer and x is not equal to z. Okay, here clearly here up to here this one. Okay, x is integer, then step of minus x only. If not, step of minus x equal to minus step x minus 1. See, for example, this you want find. What the definition? Step of minus 2, yeah, minus 1. So with what happened here? Minus symbol. Okay. So what is the step of minus 2? Minus 2. Actually here x is taken, that is positive x is taken. Okay. Step of 2 into minus 2. Totally what happened? Minus 3. That's why step of minus x equal to minus x. X should be positive inside minus 1 where x is a non-integer. Okay students, so this also explained. So this is very important. Yeah, step x plus step of minus x equal to what? Through example I will explain. If x is taken as 3 nana, step 3 plus step of minus 3. Step 3 only. Step of minus 3 only. 0. Always 0 is not correct. Sometimes you are getting 0. For example, x is taken as 3.1. What happened? I will explain. 3.1 plus step of minus 3.1. 3.1 3 only. Step of minus 3.1 minus 4. That's minus 1. Sometimes you are getting minus 1. Sometimes you are getting 0. When you will get 0? If x is integer. When you will get minus 1? X is a non-integer. I can say 0 and minus 1. So when x belongs to z, means integer. X does not belongs to z. X non-zero integer will get minus 1. X is integer will get 0. That is the property number 5. See, step x plus step of minus equal minus 1 if x is non-integer. 0 if x is integer. Okay. Yeah, students, next one is sixth one. Step x. Step x minus of minus step x. What is this? Again, divide into two pieces, integer and non-integer. If x is taken as integer, I will explain through example. Step 2 minus step of minus 2. 2 only. Step of minus 2 minus plus 2. What the meaning of that? 2 into 2 will get, that is 4 actually. So step of x minus minus or minus x equal to 2x, 2 step x I can say. If x is integer, x belongs to z, this is happens here, clearly given. If x is integer, then directly. If x is not integer, I will explain through example. For example, 2.1 is taken. Step 2.1 minus step 2.1. Step 2.1 2 only. Step of minus 2.1 minus 3. Minus 3 plus minus plus 3, I can write 2 plus 1 then. What about 2 times of 2 plus 1? What the meaning of 2 times of step x plus 1? Understood? That's why, yeah, step x minus step of minus x equal to 2 times of step x plus 1 if x is non-integer. So, remaining properties I will explain in the next part.